Hi, grade 8. This is the video for the bottom of page 32, practice quiz number 2, and for worksheet 1-6 for 8th grade pre-algebra. Okay, what I'm going to do today is, since most of the assignment's out of the worksheet, is we're going to take a look at some of what's in the textbook on page 36 and 37. I'm going to demonstrate how you would do some of that stuff on 36 and 37, and thus you should be able to do the worksheet 1-6. So if you would join me on page 36 at the top of the page. Go ahead and pause this right now until you get that available. Okay. Look at number 4 on the top of page 36. Do you see where it says H and then it says a coordinate pair of 5, 3? Hopefully you remember how to do coordinate planes, but let's just do a quick review of that. This right here, this whole thing's called a coordinate plane. It can be divided into 4 sections. Do you remember that? We can call this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Hopefully that rings a bell to you. Oh boy, this is going to be annoying if it just keeps doing that over and over again. One moment, please. Hopefully that'll keep that still. If you recall, this line is called the x-axis right here. The x-axis. This line is called the y-axis. And the middle right here is called the origin, or it's also called location 0, 0. Okay, so number 4 says, where is H if you put it at the ordered pair of 5, 3? Where is H at 5, 3? Well, 1, 2, 3, 4, 5. The first number is the x value. The second number is the y value. So if I find 5 on the x and 3 on the y, and I see where they meet, that's location 5, 3. That's location 5, 3. X value first, y value second. Find where they meet, and you're set to go. Number 6, what about 6, 0? 6, 0, well, this is 6 on the x-axis, and this is 0 on the y-axis. So 6, 0 would be this location, and we're supposed to put the letter D there. D is 6, 0. Okay? Number 6, refer to the coordinate system shown at the right. Write the ordered pair that names each point. What is location Q? What is location Q? Well, Q is right here on page 36. What is that location? Well, it's above 2 and across from 3, isn't it? We always talk about the x value first and then the y value. So Q is equal to location 2, 3. 2, 3. How about location number 7, P? Let's see, 1, 2. Okay, P is right about here. That's location P in your textbook. Where is that? Well, 1, 2, 3, 4, 5, 6. It's above 6, and it's across from 5. So P is coordinate 6, 5. Always name the x value first and then the y value. Let's look at number 8. Express each relationship as a table, and then graph, and then determine the domain and the range. So, number 8. We've got these ordered pairs. We've got 2, 5. We've got 0, 2. And we've got 5, 5. I'm going to try to do this somewhat in order. So if I have my x and my y value, I'm starting my table. I'm going to do it like this. Okay? I use 0, 2 first, and then 2, 5, and then 5, 5, because I'm trying to do them in order based on the x values, right? And then it says, graph it. So a graphing of this would be here, here, and 4, 5, 5. Okay, that would be the graphing of those spots. And then I'm supposed to determine the domain and the range. The domain in this particular situation is simply all of the x values, 0, 2, and 5. The range is just simply all of the y values, 2, 5, and 5. So I created the table for number 8. I graphed the points, and then I determined the domains and the ranges. Let's do number 9. Same thing, no big deal, hopefully. We got 1, 6, 6, 4. We've got 0, 2, 3, 1. Remember, when we graph these, we always graph the x value first. So there's my 1, 6. There's my 6, 4. Here's my 0, 2. And here's my 3, 1. Okay, so that's the graphing of these points. What else do I need to do? Oh, I forgot the table. I forgot the function table. X, Y. Okay, let's go 0, 2, 1, 6, 3, 1, and 6, 4. And finally, let's name the domain. The domain in this case is 0, 1, 3, and 6. And the range is simply 2, 6, 1, and 4. So I've got the ordered pairs, I've got the table of the ordered pairs, I've got the graphing, and I've got the domain and the range. Let's move on to number 10. Make a table of the ordered pairs in which the x-coordinate represents the number of student tickets and the y-coordinate represents the cost for 2, 4, and 5 tickets. Okay. In the directions it says it costs $4 to buy a ticket to the movies for students. So some sort of table with an x and y value, and it tells us that x, number of tickets, student tickets. X is the number of student tickets, and y is the cost, according to the directions. Okay? Number of student tickets. Well, we've got 2 tickets, 4 tickets, and 5 tickets, right? And each one of those tickets is $4, so that would be 8, 16, and 20, because it's 2 groups of 4, which is 8, or it's 4 groups of 4, which is 16, or it's 5 groups of 4, which is 20. This is problem number 10 in your textbook. That's talking about tickets compared to cost. Then number 11 says graph those ordered pairs. Okay, so how would I graph that? Well, I'm going to go by 2s here. Because if I don't go by 2s, I don't think it's going to fit, right? And I'm going to go by 2s here, 2, 4, 6, 12, 14, 16, 18, 20. Boy, it doesn't even fit on here. So 2, 8 would be right here. And 4, 16, let's see, 10, 12, 14, 16. 4, 16 would be way up there. And 5, 20 would be way up here. Notice 5 is in between 4 and 6. So I have to put that dot between, right? This is number of tickets. About number of student tickets, and over here is the cost in dollars. Can you see all that? I think you can. Yeah. And notice it's just basically a straight line right here. All right, so that's problem 11, graphing the ordered pairs, the number of tickets compared to the number of cost. Number of tickets compared to the cost, right? This is number 10, the table. Okay. Let's take a look at where we at, 9, 11. Let's keep jumping into problems on 36. Let's try number 12. 12 says graph A at location 3, 3. That'd be right there, right? 3, 3, A, bonk. How about number 13? 1, 8. 1, and then 8 would be 2, 4, 6, 8. 1, 8 would be way up there. 1, 8 would be the letter D, right? Number 14, how about 2, 7? 2, 7 would be 2 and 7, and that's letter G for number 14 according to the textbook. Enough of that. Let's go down to 18. Refer to the coordinate system shown at the right Write the ordered pair that names each point. 18 is C cap. That would be 1, what would that be? 1, 7. Problem 18, C cat is 1, 7. The ordered pair of 1, 7, parenthesis, 1, comma, 7, close parentheses. How about number 19, J jack? See, 1, 2, 7, 3, I guess. 7, 3. Number 19, J jack would be 7, 3. Always name the x value first and the y value second. Let's look at 24. 24 is an interesting question. What point lies on both the x-axis and the y-axis? What point lies just on that? Well, you could name it two ways. This point lies on both of them. You could call it the origin, or you could call it location 0, 0. Either way, that point lies on both the x and the y-axis. Let's look at 26 and 27. The average speed of a mouse is 12 feet per second. Find the distance traveled in 3, 5, and 7 seconds. 3, 5, and 7 seconds. Okay. And then in 26, they tell you to graph the ordered pairs in time versus distance. 27. So let's see. If x is time, then y needs to be distance according to what they've told us here, right? And the times they've given us are 3, 5, and 7 seconds, right? 3, 5, and 7 seconds. Find the distance traveled. Well, if they travel 3 seconds and they can go 12 seconds per, or 12 feet per second, isn't that 3 groups of 12 for 36? Because 1 second would be 12 feet, wouldn't it? So 3 has to be 36, and 5 has to be 60, and 7 has to be 84. How am I getting those numbers? I'm just multiplying by 12 each time across from the x to the y value, right? And then it says graph the ordered pairs, time versus distance. Well, I lost my graph, but if I were trying to graph that, time would have to be on the bottom because it's the x value, right? Time would have to be here, and distance would have to be over here, right? And I'd maybe go 1, 2, 3, 4, 5, 6, 7. And so I'm going by ones on the bottom, but over here, these numbers are pretty big. So I might go by, say, tens. 10, 20, 30, 40, 50, 60, 70, and 80, right? So that we can get them all on here. 112 would be about here. 336 would be about here. 560 would be about, let's see, 30, 40, 50, 60. 560 would be about here. And 784 would be way up here. So this would be what, 20, 30, 40, 50, 60, 70, and 80. So that would be the graphing. Time compared to distance, problem 27. Okay, hopefully this helps you, 8th graders. Hopefully this helps you. If not, talk to me.